Today we are going to start infinite series. First of all, see definition of infinite series. Infinite series. Its definition is the infinite series of real numbers u1 plus u2 plus u3 plus so on un plus so on till infinity is called infinite series. It is denoted by summation n varies from 1 to infinity un or simply summation un. Therefore, summation un equals to u1 plus u2 plus so on un plus so on till infinity. In this topic, you have given series summation un equals to u1 plus u2 plus un plus so on till infinity, and you have to find un means nth term of the series for checking convergence and divergence of infinite series. We have about 9 tests to discuss for convergence and divergence of an infinite series. Next, very important result, necessary condition for convergence of a positive term series. This is also called as test of divergence. If a positive term series summation un is convergent, then limit n tends to infinity un equals to 0. Whenever tests among the 9 tests fail, only then we use it. Don't use this test for divergence directly. If limit of un comes out to be finite, then series is called convergent. Otherwise, series, if limit n tends to infinity, un equals to infinity, then series is divergent. If limit is not unique but finite, say value of limit come out to be 1 or -1, or simply means if it has more than one value, then it is called oscillating series. Then it is called oscillating series. Next, very important test called helping test. Helping test or P test. Helping test or P test. The infinite series, the infinite series of the form summation 1 over n raised to power p. Here n is single term and p is any constant of positive terms of positive terms is convergent is convergent if p greater than 1 and divergent if p less than equals to 1. Use p test if it is of the form 1 over n raised to power p, that is some power of single n in denominator is given and in numerator 1 is given, like summation 1 over n square, summation 1 over n cube, summation 1 over n raised to power n, summation 1 over n raised to power 1 by 2. Next is comparison test. Next we have comparison test. In this, we do comparison of two series, namely say summation series un and series vn. We discuss three cases in comparison test. So see case number 1. What is case number 1? If summation un and if series un and series vn be any two positive be any two positive term series and series vn and series vn is convergent. This is convergent. Also, series un is smaller than series vn for all n. There exists a non-zero integer k, non-zero integer k such that un is less than equals to k times vn for all n, then the series un is also convergent. Then the series un is also convergent. Means if bigger series converges, then smaller series also converges. This test simply says if larger series is convergent, then smaller series is also convergent. Now see case 2. If series un and vn be any two positive term series and there exists a real number k such that un greater than equals to k times vn for all n, and series vn is divergent, then series un is also divergent. Means if smaller series is divergent, then bigger series is also divergent. Never use directly above two cases in questions. If automatically comparison arises, then we can use above two cases. Only then we can use above two cases. Our in comparison test, if we have in any series terms like x terms or factorial or increasing multiples like 1 by 2 plus 1 into 3 over 2 into 4 means 2 terms, the next 3 terms, then never use comparison test. Then never use comparison test. Means terms are increasing multiples. If given series don't have x term, factorial term or increasing multiples like 1 by 2. Here first term contain one term. Second term is suppose this. Two terms. Next 1 into 3 into 5, 2 over 4 into 6 plus 1. Here it is one term. Here it is two term. Here it is three terms. So terms are increasing. So if we have x term, factorial term or increasing multiples in un term, then never use comparison test. Here we use ratio test. Here we use ratio test. So we never use comparison test for these three conditions. Now see case number 3. See case number 3. In case number 3, see if series un and series vn be two positive term series and limit n tends to infinity, un over vn is finite and non-zero. Value of limit should be finite and non-zero. It may be like 2, 3 means finite and non-zero. Then if series vn is convergent, then series un is also convergent. And if series vn is divergent, then series un is also divergent. Means both series behave alike. Both series behave alike. Now observe all the three cases. If series vn is convergent, then series un is also convergent. And if series vn is divergent, then series un is also divergent. So behavior of series UN clearly depends upon the behavior of Vn. Note one thing. In questions, only one series is given to you. That is UN series. But in above comparison test, we have to compare or we have two series. Now, question arises from where series Vn comes so that we can apply comparison test. The series UN always. So our motive is to determine series Vn according to series UN. Whatever series is given in question, it is always UN series, and we have to find Vn series according to UN series. Our Vn should be like summation 1 over n raised to power p always. In comparison test, Vn series Vn series should always be like p test, helping test. We know by p test, if p is greater than 1, then Vn is convergent, and so Un will also be convergent. And if this p less than equal to 1, then series Vn is divergent. So Un will automatically divergent. See one example based on it, based on comparison test. Statement is examine for convergence or divergence of the series 1 upon 1 into 2 into 3 plus 1 over 2 into 3 into 4 plus 1 over 3 into 4 into 5 plus so on till infinity. See its solution. The given series is summation Un equals to 1 over 1 into 2 into 3, 1 over 2 into 3 into 4, 1 over 3 into 4 into 5 plus so on till infinity. Remember one thing. You have to take given series as Un always. Now, our first step is to find nth term, that is Un term. If series is given in expanded form, U1 plus U2 plus U3 plus so on, our first step is to find nth term of the given series. Here U1 is this, U2 is this, U3 is this. So Un will be, we can find Un in two ways. First, one is by comparing suffix on account of symmetry. In Un, we have 1 in denominator. In U2, we have 2. In U3, we have 3. See here it is. For U1, we have 1. For U2, we have 2. For U3, we have 3. So in Un, we have n in denominator. Next in Un, we have 2 consecutive term of 1 means 1 plus 1 is 2. In U2, we have 3. 3 consecutive term of 2 means 2 plus 1 is 3. Here 4 is 3 plus 1. So in n, un next term will be n plus 1. Now in first is see first term of u1, next term is 3. Here next term is 4. In u3 next term is 5. There are three consecutive terms. Here again three consecutive terms. Here again three consecutive terms. So in un there will be three consecutive terms, means n plus 1, and next will be n plus 2. See numerator. Numerator of u1 is 1. Numerator of u2 is 1. Numerator of u3 is 1. So numerator of un will be 1. This is on basis of account of symmetry. On basis of account of symmetry. Or second way is to find with the help of nth term of AP series. If difference between two terms is more than 1 means here difference is 1. If difference is 1, we find nth term on account of symmetry by comparing suffix. But if difference is more than 1, then we use nth term equals to a plus n minus 1 into d. Second way is to find with the help of AP series. And AP series nth term formula is a plus n minus 1 into d, where a is first term and d is common difference. Here clearly difference between terms of u1 and u2 and u3 and so on is 1. So we can directly write un by comparing suffix, and if difference is more than 1, we can use formula of nth term of AP series. Now next step is to take higher powers of n common. Remember this thing. Next step is to take higher powers of n common. Why? Why we take higher powers of n common? Since we have to use test, for that we have to put limit n approaches to infinity. If n will be in the numerator, then it will lead to infinity. If n is in the numerator, it will lead to infinity on taking limit n approaches to infinity. To remove that infinity, n should be in fractions because 1 over infinity is 0. So we always take higher powers of n as common in every test. Test may be comparison test, ratio test, Rabi's test. In every test, we have to take higher powers of n as common. Now, whatever higher power of n is common in denominator, consider that as Vn. Consider that as Vn. Now, we will take higher power of n common. See, from here, we can take n common. Inside the bracket, it will be this. From here, we take n common. Inside the bracket, it will be this. Now, n into n into n. It will be n cube into 1 plus 1 by n into 1 plus 2 by n. Next step is to find Vn, and Vn is depending upon the higher power of n, which is taken common. So, therefore, Vn will be 1 upon n cube. Vn will be 1 upon n cube. In every question, n will be in fraction, like 1 by n, and not in n form, as we have to take limit n tends to infinity. Important notes: if in un we don't have higher powers of n common, like n cube, then we are unable to find Vn. So in that case, we can't apply comparison test. If we are unable to find Vn, then how we can apply comparison test. For comparison test, we need Vn. In that case, we use previous discussed result, which is necessary condition for convergence of a positive term series. Next step, after finding un and vn, next step is to find un over vn. Next step is to find un over vn. It will become 1 over 1 plus 1 by n into 1 plus 2 by n, because n cube will get cancelled out. What is next step? Next step is to take limit n tends to infinity. So limit n tends to infinity, un over vn will be 1 over 1 plus 1 over infinity 0, 1 plus 0, 1. 1 plus 2 over infinity. 2 over infinity is 0 and 1 plus 0 is 1. 1 into 1 is 1. So limit comes out to be 1, which is finite and non-zero. Now see, limits comes out to be finite and non-zero. So therefore, by comparison test, therefore by comparison test, series will behave alike. Series un and series vn will behave alike. Behaves alike means if vn is convergent, then un is also convergent. If vn is divergent, then un is also divergent. Here, series vn is 1 over n cube. By p-test, here p is 3, which is greater than 1. Therefore, series V is convergent. As series behave alike, if Vn is convergent, then by comparison test, series un is also convergent. Series un is also convergent. Now see one more example of comparison test. Remember one thing, if un contain x term, factorial term and increasing multiple term, then never use comparison test. Then we have to use ratio test, which we will discuss later on. See, examine for the convergence or divergence of the series square root of n plus 1 minus square root of n divided by n raised to power p. Here see, un is directly given. Series is not in expanded form like u1 plus u2 plus un plus u1. So un is directly given, so no need to find the value of un. So here un is square root of n plus 1 minus square root of n upon n raised to power p. Note one thing. Whenever un is in square root terms, like under root a minus under root b in numerator or in denominator, always rationalize it. Always rationalize it. So when we rationalize, minus sign will become plus. We will get under root n plus 1 plus under root n over under root of n plus 1 plus under root n. Now, next step is a minus b into a plus b. It will be a square minus b square. Therefore, un will be a plus b minus a square minus b square. So it will be like this. And in denominator, we have n plus 1 plus under root of n. Here n will get cancelled out. We are left with 1 over n raised to power p into under root of n plus 1 plus under root n. Now, what is next step? After rationalization, we have to take higher power of n common. So, from here, we have to take under root n common. Taking higher power of n common means taking under root n common. What we will get? un equals to 1 over n raised to power p into under root n into under root of 1 plus 1 by n plus under root n get common. So here it is only 1 as under root n is outside the bracket. What we have done? We have taken higher power of n common. Now next step is bases same, powers are added. Under root n means n raised to power 1 by 2. What we will get? N raised to power p plus 1 by 2 into under root of 1 plus 1 by n plus 1. This is our un. Next step is to find vn. And what is vn? What will be value of vn? The highest power of n which is taken common, highest power of n, which is p plus 1 by 2. So clearly vn will be 1 over n raised to power p plus 1 by 2. After finding vn, what is next step? To find the value of un over vn. Therefore, un over vn. It is 1 over under root of 1 plus 1 by n plus 1 because n raised to power p plus 1 by 2 from numerator and denominator will get cancelled out. What is next step? To take limit n tends to infinity. So limit n tends to infinity un over vn equals 1 over infinity 0 square root of 1 1 plus 1 2. So it will be 1 by 2. Which is finite and non-zero, which is finite and non-zero. If limit value is finite and non-zero, therefore by comparison test, series will behave alike. Series un, series vn will behave alike. Behaves alike means if vn is convergent, un is also convergent. If vn is divergent, un is also divergent. Now here Vn series is, here series Vn is 1 over n raised to power p plus 1 upon 2. But we are not sure here power is greater than 1 or less than equal to 1. So we have to write all the cases. See how? Vn is convergent if p plus 1 by 2 greater than 1. That is if p greater than 1 by 2. And divergent if p plus 1 by 2 less than equal to 1. That is if p less than equals to 1 by 2. Therefore, series UN is convergent for p greater than 1 by 2 and divergent for p less than equals to 1 by 2. In brief, what are steps for comparison test? In comparison test, first you have to consider given series as UN. In UN, you have to convert all n terms into fraction like 1 by n by taking higher powers of n common. And what we get, higher power of n common in denominator, we have to consider it as or suppose it as Vn series. And Vn must be of the form 1 over n raised to power something. Next step is to find un over Vn. Next step is to find limit n tends to infinity un over Vn. Either it will be finite or either it will be finite or infinite. If it is finite and non-zero, then series behave alike. Next, it may be of Vn may be of form p-test. In p-test, we have to discuss convergence. If p is greater than 1, series is convergent, and if p is less than equal to 1, series is divergent. If Vn is convergent, series un is also convergent. If Vn is divergent, series un is also divergent. See one more example. Examine the convergence of the series 1 over under root 1 plus under root 2 plus 1 over under root 2 plus under root 3 plus 1 over under root 3 plus under root 4 plus so on till infinity. Now, first step is to find un with suffix method. Nth term by observing behavior of symmetrical terms. Let u1 is this. Let u1 is this. This is u2. This is u3. Then what will be un? See in numerator, first term of u1, numerator is 1. First in numerator of u2 is 1. Numerator of u3 is 1. So numerator of un will also be 1. Same denominator. What denominator of un? First term of u1 is square root 1. First term of u2 is square root 2. First term of u3 is square root 3. So first term of un is square root of n. Next is plus in every term. Here for under root 1 we have under root 2. Under root 2 is 1 plus 1, 2. For under root 2 we have under root 3. Means 3 is consecutive term of 2. For under root 3 we have under root 4. Means 4 is consecutive term of 3. So for under root n we have under root n plus 1. After finding un, you have to check whether it is correct or not. How? Put n equals to 1 and check what we will get. We will get u1. Put n equals to 2. What we will get? Same term as in u2. Put n equals to 3. What we will get? Same term as in u3. So our un is correct. So our un value of un is correct. You can also find nth term with the Tn formula, but here difference is 1. If difference is 1, we can directly find the value with the help of symmetry. With the help of symmetric. Next step is after finding un. Next step is taking the higher powers of n as common. So let's take under root n as common, and inside the bracket we are left with 1 plus under root of 1 plus n. So whatever higher power of n is taken common, we have to post this term as Vn. Therefore, Vn will be 1 over under root n. Next step is to find un over Vn. It will be 1 over 1 plus under root of 1 plus 1 by n, as 1 over under root n will get cancelled out from numerator and denominator. Next step is to find limit. To take limit n tends to infinity un over Vn. 1 over infinity 0. 0 plus 1, 1. Square root of 1, 1. So 1 plus 1, 2. What we will get? 1 by 2, which is finite and non-zero. So by comparison test, therefore, by comparison test, series un and series vn will behave alike. Now, series vn is 1 over n raised to power 1 by 2. Now we have to use p-test. So here p is 1 by 2 and 1 by 2 is less than 1. So series Vn is divergent by p-test. Therefore, series Vn is divergent by p-test. There implies series un is also divergent by comparison test. By comparison test, un is also convergent. See one more example based on comparison test. One more example. Examine the convergence of the series 1 plus 1 by 2 square plus 2 square by 3 cube plus 3 cube by 4 raised to power 4 plus 4 raised to power 4 by 5 raised to power 5 plus so on till infinity. First step is to find un. Firstly, make the symmetry. If we come from right to left, if we come from right to left in denominator, we observe first 5 raised to power 5, then 4 raised to power 4, then 3 raised to power 3, then 2 raised to power 2, and we write first term as 1 raised to power 1. Now observe numerator. 4 raised to power 4, 3 raised to power 3, 2 raised to power 2, 1 raised to power 1. And here we can't write 0 raised to power 0. We can't write it as 0 raised to power 0 because 0 raised to power 0 is not equal to 1. 0 raised to power 0 is not equal to 1. And it leads to indeterminate form. That means what we need to do, see, sometimes there are infinite number of terms. If we neglect or omit any one term from infinite series, or if we add any one term in infinite series, the convergence of the series will not get affected. Then it will not affect the convergence of the series. Getting my point? If from infinite number of terms, if we neglect one or two terms, it will not get affected. It will not affect convergence of the series since first term is not making symmetry as a numerator. First term symmetry is not formed, so for finding un, we have to make symmetry in series. For that, we will neglect first term. So we will check convergence of the series 1 over 2 square plus 2 square upon 3 cube plus 3 cube upon 4 raised to power 4 plus 4 raised to power 4 upon 5 raised to power 5. Write down neglecting first term. Neglecting first term. Now we have to check convergence of this series. Firstly, check numerator because we have to find the un of this series on account of symmetry. In numerator, in u1 we have 1 raised to power 1. In u2, say this is u1, this is u2, this is u3, this is u4. So what will be un in numerator? See, for u1 we have 1 raised to power 1. For u2 we have 2 raised to power 2. For u3 we have 3 raised to power 3. For u4 we have 4 raised to power 4. So for un we will have n raised to power n. See, in denominator we have 2 raised to power 2. For u2 3 raised to power 3. For u3 4 raised to power 4. For u4 5 raised to power 5. So for n we have n plus 1 raised to power n plus 1. We have un, neglecting first term. You can check whether it is right or wrong. By putting n equal to 1, see, we will get u1. By putting n equal to 2, we get u2. So it is correct. Next step is to take higher power of n common to make n in fractions. So therefore, un is taking n common. What we will get? Now this power will comes with this factor and this factor. What we will get? N raised to power n upon n raised to power n plus 1 upon 1 plus 1 by n raised to power n plus 1. Now splitting the powers. Splitting the powers. N plus 1 power will split out in power n and power 1. N raised to power n will get cancelled out. What we will get now? 1 over n, 1 plus 1 by n raised to power n, 1 plus 1 by n. This is our nth term. Next step is to find Vn. Take Vn as higher power of n common outside the bracket. So here it is n. So let Vn equals to 1 by n. Next step is to find un upon Vn. We will get next step is to take limit. You know one result, limit n tends to infinity, 1 plus 1 by n raised to power n. It is e. So this is e. 1 upon infinity, 0. 0 plus 1, 1. E into 1. E into 1 is e. What is the value of e? 2.713. So 1 upon 2.713. It is non-zero and finite. Therefore, by comparison test, series un and vn will behave alike. Now, see series vn. Because if vn is convergent, un is also convergent. If vn is divergent, un is also divergent. See vn. Series vn is this, which is of the form 1 over n raised to power p. Here p is 1. Therefore, series vn is divergent by p test. Therefore, series un is also divergent by comparison test. See one more example. Examine the convergence of the series summation under root of n raised to power 4 plus 1 minus under root of n raised to power 4 minus 1. Here un is directly given, so no need to find the value of un. Given un equals to under root of n raised to power 4 plus 1 minus under root of n raised to power 4 minus 1. It is of the form under root a minus under root b. So we have to rationalize it. On rationalization, what we will get? This minus will become plus. A minus b, a plus b. It is a square minus b square. A square minus b square. Now n raised to power 4 will get cancelled out. Minus minus plus 1 plus 1, 2. It will become 2 upon under root of n raised to power 4 plus 1 plus under root of n raised to power 4 minus 1. Now to find Vn, we need to take higher power of n common, that is square root of n raised to power 4, which is n square. For Vn, take higher power of n common outside the bracket. Here it is n square, so Vn is 1 over n square. Let next step is to find limit n tends to infinity un upon Vn by comparison test. When we divide this, 1 over n square will get cancelled out. What we will get? On putting n tends to infinity, this will become 0. 1 plus 0 is 1. Under root of 1 is 1. Similarly, here under root of 1 is 1. What we will get? 2 upon 1 plus 1, 2. 1, which is finite and non-zero. Therefore, by comparison test, it is un and vn will behave alike. Consider series vn. Here, p is 2, which is greater than 1, implies series vn is convergent by p test. Therefore, if series un is also convergent by comparison test. Comparison test is also called limit comparison test.